Hi there. Let us talk about Blaise Pascal and his principle on fluid pressure. In this lesson, we shall define the principle and explain what it means. First, what is a fluid? A fluid is any substance that can flow easily and has no fixed or definite shape. From this definition, I bet you already have some ideas on what they are. Examples are gases like the air you breathe, the gas in your cooking cylinder, and the gas in your balloons. Liquids are also fluid. Common examples of liquids are water or oil. Have you ever considered what happens when you apply a force on a fluid? Well, if you have, then you're not the first. Blaise Pascal, who was a French mathematician, physicist, inventor, and theologian, decided to study fluids and how they behave when a force is applied to them. His discoveries on this lead to numerous applications. We shall look at a few in our lesson on the applications of Pascal's principle. Now let's look at what happens when you apply a force on a liquid. Assuming you have a cylindrical bucket of water and you fill it halfway with a liquid like water. If you have a lid that is exactly the size of the cylinder and you push it on the liquid, then you will be applying a force on this liquid. This force will be applied over an area on the liquid which is equal to the area of the surface of the liquid. But when a force acts over an area, we call it pressure. This implies that the force you applied is experienced as pressure by the liquid. But what you will notice is that the force is exerted on the molecules of the liquid on the surface. Now, how does it affect the remaining water molecules in the bucket? Let us assume a different illustration for this. Assuming you and your classmates are on the school field, and your teacher asks you all to stand in a small square drawn on the field that is barely enough for you all to fit in. Now, if he decides to push the person standing at one edge of the square, what you would realize is that the person will move and push the next person behind and beside him or her. These two will also do the same to the persons behind and beside them. This will continue until everyone experiences the push. This implies the push, which is a force exerted on one person, is a push on everyone and will be experienced by you all. But what if there's a wall at three sides of the square and your teacher uses a plank of wood to push at this end? All these standing at the edge of the plank will push those beside and behind them, right? This push will continue until those closest to the wall will start to push the wall. But since the wall is not movable, and according to Newton's third law of motion, the walls will exert a force that is equal and opposite to the push. This implies they will also start to push with a force in the opposite direction. This opposite push will also be exerted on everyone until it gets to those closest to the plank. They will also push back at the plank. And from this analogy, we can say the force applied at one side exerts equal pressure on everyone in the square. We can also say this pressure is equally exerted on all three walls. And we can also say the plank is equally experiencing the same pressure due to Newton's law of motion. This is similar to what happens to the water molecules in the bucket. This is the reason why you also feel you can't push the lid further. It feels like the water is pushing back. This is what Blaise Pascal discovered and stated in the principle named after him. This principle states that when pressure is applied at any point on an incompressible fluid placed in a confined container, the pressure is transmitted throughout the fluid. This implies for a fluid that is incompressible, any pressure you apply at any point will be experienced by all the molecules in the fluid. So we can say, according to this principle, what happens to one is shared by all. Think about this and see you in the next lesson.